Okay, in the last video, we saw example where we had the improper integral from 1 to infinity of 1 over x dx, which was divergent, and the integral from 1 to infinity of 1 over x squared dx was convergent. And so we now want to ask and answer the question for which values of p is this improper integral convergent or divergent? Okay, we already know for p equals 1, right? So we've already shown, so for p equals 1, right, we have this integral, 1 over x dx. It is divergent. We saw that in the last video. It is divergent. So let's now consider when p is not equal to 1. All right? So we're going to consider this limit, the limit as t goes to infinity, so let's say it's not equal to 1, of 1 to t, 1 over x to the p, which I'm going to write as x to the negative p dx. We're going to consider that limit. All right? Now, it's back to just answering this question right here. Let's find that definite integral here by using the power rule. So we get what? X to the negative p plus 1 over negative p plus 1. We're going to evaluate from 1 up to t. And after we do that, we'll come back and take the limit as t goes to infinity. All right? I'm going to write this a little bit differently just so that we can process what's happening here. So I'm going to write this as x to the 1 minus p over 1 minus p, first and foremost, and then 1 to t. And then t to infinity. I'll even pull out the 1 over 1 minus p, right? Because we know constants can come out of a limit. 1 over 1 minus p. So we're really left with t to the 1 minus p minus 1. Okay, so that's, the 1 clearly goes to 1. So the real question is what's going on right here, right? And that depends on whether you have something like 1 over t to some power, right? I'll make it like m, where m is positive, and then in which case that's going to 0. Or if you have something like t to the m, so by the way, m greater than 0, then this thing is going towards infinity. So this is if we have this scenario right here, it'll converge. If we have this scenario, it'll diverge. And so we're requiring that power on t. Okay, so let's talk about that. So if 1 minus p, let's say, is negative, then t to the 1 minus p is equal to 1 over t to the p minus 1, right? That means p is, what? Bigger than 1. Then this thing becomes, that right there is positive, and this goes towards 0. Okay, so process all those inequalities. Okay, if 1 minus p is greater than 0, so we have t to the 1 minus p, that's greater than 0, then this whole thing goes towards infinity. And that is when p is smaller than 1, right? So, to recap, this piece right here goes towards 0 if p is bigger than 1, and it goes towards infinity if p is less than 1. That's what we have right here. So, to answer our question, we would say this thing converges when p is greater than 1, and it diverges when it's less than 1. We already know that it diverges when it's equal to 1, so we can say when p is less than or equal to 1. That's going to be important in this section as well as when we get to series. So make sure you know that one.